In this video, we are going to evaluate the derivative of logarithmic function. Since no other method is applicable in logarithmic function, we are going to be evaluating how to solve for logarithmic function. But before we go into solving of logarithmic function, we need to talk about how do we solve natural logarithm first. You understand? We have done chain rule, and I'm sure that we are much more familiar with the concept of chain rule now. We're going to be doing some examples where we'll be applying chain rule in solving natural logarithm function. And the first question, let us take our first question to be our y equals to ln x, right? We know that for ln x, our dy over dx equals to 1 over x, right? Also, if you have something like y equals to ln 2x, our dy upon dx will be equals to 2 over x. Also, if you have something like y equals to ln 3x, our dy upon dx is going to give us 3 over x, and so on and so forth. You understand? So, if you have something like y equals to ln x squared, in this case, how are we going to be solving this? We're just going to use the concept of chain rule like we have used before. We're going to say that let our u equals to x squared and our y is going to be equals to ln u. Therefore, our dy over dx will be equals to 2x, and our our du upon dx, our du upon dx, and our dy over dx du will be equals to what? Will be equals to 1 over u. 1 over u. Therefore, our answer is going to be dy upon dx is going to be 2x multiplied by 1 over u, and that's going to be 2x divided by what's our u? That's x squared. Therefore, I can use one of the x to cancel x here, and our answer will still remain 2 over x. You understand? So this is how to solve whenever we are having something like this. What if you're having something like y equals to ln 3x, ln x is power 3 rather, ln x is power 3. We're just going to say that our y equals to ln u because our u equals to x is power 3. Therefore, our dy over du is going to be 1 over u, and our du over dx is going to be what? Is going to be our du upon dx is going to be 3x squared, right? Therefore, our dy over dx is now going to be giving us 3x squared multiplied by 1 over u, which is 1 over x cubed, right? So x squared is going to cancel 2 of the x here, and we're going to be having 3 over x, which is similar to what we got for ln 3x. You understand? Now, what if you're having a question like y equals to ln of x squared plus 4? How are we going to look for this? Same method. We're just going to see that our y equals to x squared, sorry, our u will be equals to x squared plus 4, and our y will be equals to ln u. Therefore, our du upon dx is going to be equals to 6x. Okay. It's going to be equals to 2x rather, 2x, and our dy upon du is going to be equals to 1 over u. So same thing what we have been doing. We're just going to say that our dy over dx is going to be 2x multiplied by 1 over u, which is 1 over x squared plus 4, right? And that's equals to what? That's equals to 2x divided by x squared plus 4. That is our answer for this particular question. So as simple as that. That's how simple we can use this thing. You understand? Let us take for an example. We have our y to be equals to, let us say they say we should look for ln of sine x. Very easy, right? We're just going to see that our u is going to be equals to what? Our u equals to sine x, and our y is going to be equals to 1 over u. Our y equals to ln u rather. Therefore, our du upon dx is going to be giving us cos x, and our dy upon du is going to be giving us 1 over u. Therefore, our dy upon dx will be equals to cos x multiplied by 1 over u, which is 1 over sine x, and that is equals to what? That is equals to cos x over sine x, which is equals to cot x. That's cotangent cot x. As simple as that. So that's how you can solve functions like this. You understand? That's how you can actually solve functions like this. Let's take for an example. Let us say we have something like y equals to ln of 7 root x. You know that 7 root x or 7th root x is the same thing as y equals to ln of x raised to power 1 over 7, right? It's still the same thing. It's the same thing as x raised to power 1 over 7. Now, remember from the law of log, if you have log a log ab raised to power n, this n will come to the graph and become n log ab, log of base ab. You understand? Now, which means this 1 over 7 can come to the back, and we're going to be having 1 over 7 ln x. You understand? So the next thing is that I can now differentiate my ln x, and I'm going to be having our dy over dx to be equals to 1 over 7 multiplied by 1 over x, and that's equals to 1 over 7x. You understand? That's the answer for this particular question. So we are going to be using, because logarithm and natural logarithm, they work with the same formula, they work with the same rule. You understand? They follow the same rule. Now let us solve a question under logarithmic function. Let's say we have a question like y equals to log 3 log of base 3x. This is the question that we are told to solve. See, whenever you want to solve a question like this, just have it in mind that if y equals to log au, therefore our dy over dx equals to differentiation of u, which is u prime, divided by u itself, then ln a. So this u prime is the same thing as the u upon dx. Remember I told you, instead of using Lebesgue's function, we can use normal function. So if you see something like y prime is the same thing as, you understand, if you see something like y prime, if you see something like f of prime x, is the same thing as dy over dx. So u prime is the same thing as differentiation of u, you understand? So in this case, what are we going to do? It is just equals to, what is our u? Our u equals to, we just said our u equals to 1, right? So if you have something like this, so our u equals to x, sorry, our u equals to x, because this is our u equals to x. So if we say u prime, that's differentiation of x, and that will give us 1. You understand? That will give us 1. And our a is our base, that is 3. You understand? Which means you want to write this one now. Very, very simple. What's our u prime? 1 divided by u, which is what? Which is x ln a, which is 3. And this is our answer for this particular question. Not hard, right? Let's take for an example. Let's say we have something like y equals to log of 4x squared. So what's our u? Our u equals to x squared. What's our u prime? Our u prime is differentiation of u, which is 2x. What's our a? Our a equals to 4. Therefore, our dy over dx equals to u prime divided by u ln a, which is equals to 2x, because that is u prime, divided by u, which is x squared. So x squared ln 4. This is our answer for this particular question. Simple as that, right? So if we have something like log, let's say that we have y equals to log of 7 of base 7 2 or 5 minus 2x. 5 minus 2x. What will be our u? Our u is going to be 5 minus 2x. Our u prime, which is differentiation of u, is going to be minus 2. And our a is going to be what? Our a equals to 7. Therefore, our dy upon dx will be equals to u prime divided by u ln a, which is equals to u prime, that is minus 2, divided by u, which is 5 minus 2x, then ln 7. This is our answer for this particular question. So it is not hard. Logarithmic function, it is not that very difficult. So if you have something like y equals to okay. Oh, so let's say y equals to what? Y equals to log of base 2 into bracket 3x minus x is power 4. The same way we used to do it. Our u equals to 3x divided minus x is power 4, right? And our u prime is going to be giving us 3 minus 4x cubed. And our a equals to 2. Therefore, our answer is going to be dy over dx. That's equals to u prime, that is 3x minus 4x cubed, divided by u, which is 3x minus x is power 4, lane what? Lane 2. And this is our answer for that particular question. So this is how to solve logarithmic function. You understand? This is how to solve logarithmic function. Let us say we have something like y equals to log of base 5 tan x. What are we going to do? Our u is going to be equals to tan x. Our u prime is going to be sec squared x. And our a is going to be 5. So our dy upon dx is going to be u prime, which is sec squared x, divided by u, which is tan x, then a lane of what? Lane of 5. And this is our answer for this particular one. You can just put this one inside brackets to be safe. You understand? So this is how to solve logarithmic function. You understand? This is how to solve logarithmic function. It's not very difficult. Let us now take for an example. Let us say we said we should differentiate y equals to x raised to power of x. We are now looking for, we are using logarithmic function to look for this particular function. You understand? How are we going to solve this particular function? Very easy. You see, if we want to turn a power, you understand, if you want to bring down something like a power like this, we can use logarithm. You understand? We can use logarithm to bring down powers. I get what I'm trying to say. But in this case, I don't want to use log. I can use lane. You understand? Lane, which is natural logarithm. Remember, I told you that natural logarithm and logarithm, they follow the same distance. And remember, I told you that the log a raised power n equals to what? Equals to n log a, right? So if I want to take this down, this power that is here, I can say that I can lane the both side. So that is lane y equals to what? Equals to lane x is power x. And this one can come to the back. That is lane y equals to what? Equals to x lane x, rather. X lane x. So this is the first thing that I'm going to do. The next thing I'm going to do is to differentiate the both side. So if I differentiate the both side, in differentiating this one with respect to y of lane y, and differentiating this one with respect to x of lane x, of x lane x, I'm going to be having this one to be equals to what? This one will be equals to 1 over y. But you know I'm differentiating with respect to y, right? So I'm just going to say that 1 over y dy over dx. Very important for me to add this. Equals to, now if I want to differentiate this now, you see that the relationship between them is product. So I'm going to use product rule, right? And using product rule, our u will be equals to x, our v will be equals to ln x, our du upon dx is going to be equals to 1, and our dv upon dx is going to be equals to what? Is going to be equals to 1 over x. So the next thing is that I can multiply this one with this one and multiply this one with this one, right? And I'm going to be having what? I'm going to be having it to be x multiplied by 1 over x. That will be equals to 1 because x multiplied by 1 over x will cancel x and we'll be left with 1 plus 1 multiplied by ln x, that will be equals to ln x, which means in differentiating this particular side, I have 1 plus ln x. So that is equals to 1 plus ln x, right? Now, the next thing is I can now what? I can now multiply the both side by y. You understand? Multiply both side by what? By y, which means y multiplied by 1 over y dy over dx equals to y multiplied by 1 plus ln x. y cancel y. I'm left with the y over the x because that's what I'm looking for. And in this case, y, what's our y? Our y equals to x raised power x, which means that is x raised power x into bracket 1 plus ln x as our answer. So this is our answer for this particular question. So if you're having a question like this, the best way you can solve it is to use this particular method that I've just used, and you're going to be getting your answer easily. So in the next video, we are going to continue on another method of differentiating. Thank you and God bless. Make sure you subscribe and follow for more. Thank you.